The secret of the world without light. More than 71% of Earth's surface is covered by oceans. Yet despite centuries of exploration, humanity has only uncovered a tiny fraction of this immense underwater world. Beneath the sunlit surface lies a vast ecosystem where millions of species have evolved together through an endless cycle of survival spanning millions of years. What is even more astonishing is that most of the ocean remains beyond our reach. Nearly 90% of its volume exists in near total darkness, forming an alien realm completely unlike the seas we know. As sunlight fades with increasing depth, the ocean enters a mysterious transition zone known as the twilight zone, stretching from roughly 200 meters to nearly 1,000 meters below the surface. Here, only faint traces of sunlight remain. The light is far too weak to support photosynthesis, yet it is still enough to distinguish day from night. Every creature living in this zone has adapted to dim conditions, colder temperatures, and an ever-dwindling food supply. But the twilight zone is only the beginning. Beneath it lies the midnight zone, extending to depths of nearly 4,000 meters. At this level, sunlight never reaches. There are no sunrises, no sunsets, no natural light of any kind. For millions of years, this environment has remained almost unchanged. Isolated from waves, tides, and the weather above, the midnight zone has become one of the most stable, and at the same time, one of the harshest ecosystems on Earth. Far below lies the abyssal plain, where the seafloor stretches endlessly, like a vast desert of fine sediment. Beyond that are immense ocean trenches carved by Earth's tectonic forces, descending for miles into the planet's crust. The crushing pressure at these depths is powerful enough to destroy nearly any conventional machine. For centuries, these extreme depths remained beyond human reach. It wasn't until the late 20th century that advances in deep-sea submersibles and remotely operated vehicles finally opened a window into this hidden world. One of these modern robotic explorers is capable of descending thousands of meters beneath the surface. Connected to its support vessel by a specialized tether, it carries ultra-high-definition cameras and powerful floodlights, allowing scientists to capture scenes that no human eye had ever witnessed firsthand. As the robot begins its descent, the ocean transforms dramatically. The brilliant blue fades away. The light slowly disappears. The temperature drops sharply. All that remains is an endless expanse of black. Yet within this seemingly lifeless darkness, evolution has produced one of the most extraordinary collections of organisms on Earth. Creatures that generate their own light, eyes so enormous they can detect the faintest glow, jaws lined with razor-sharp teeth, bodies so bizarre they appear to belong on another planet. Every species here possesses remarkable evolutionary adaptations that allow it to survive under crushing pressure near freezing temperatures of about 4 degrees Celsius, 39 degrees Fahrenheit, and an environment where food is incredibly scarce. In this world, only the most perfectly adapted can endure. And from the darkness that once seemed endless, an entirely different world is finally beginning to reveal itself through the lens of human exploration. The midnight zone. Life in the world without sunlight. As the submersible continues its descent, every trace of sunlight disappears. Ahead lies nothing but endless darkness, a vast, silent void where the distance between living creatures can stretch for hundreds of meters, sometimes even miles. This is the midnight zone, one of the harshest environments on Earth. Water temperatures remain between 2 and 4 degrees Celsius year-round, while pressure climbs to hundreds of times greater than at the ocean's surface. Any object lacking extraordinary strength would be crushed almost instantly. Yet against all odds, life doesn't merely survive here. It thrives in ways unlike anything found on land. Food is incredibly scarce. Most of the nutrition sustaining this ecosystem arrives from above in the form of marine snow, a slow, continuous shower of dead organisms, organic matter, and microscopic debris drifting down from the upper ocean. Because meals are so rare, deep-sea animals cannot afford to waste energy. Instead of constantly swimming in search of prey, many species rely on an entirely different strategy. They wait. One of the most noticeable adaptations among deep-sea creatures is their remarkably soft, flexible bodies. Unlike the rigid skeletons of shallow waterfish, many species are built with gelatinous tissues that allow them to withstand crushing pressure without collapsing. Their metabolism is equally extraordinary. Everything happens more slowly here. A single meal can sustain an animal for weeks, or even months. One remarkable example is the Greenland shark. It is one of the longest-lived vertebrates ever discovered. Some individuals are estimated to be more than 400 years old. They grow at an astonishingly slow pace, adding only a few centimeters each year, yet can eventually exceed 6 meters in length. That incredible lifespan is made possible by an extremely slow metabolism, a vital advantage in an environment where food is so difficult to find. But conserving energy is only part of the survival equation. Many deep-sea predators have evolved hunting strategies unlike anything seen in the sunlit ocean. Rather than chasing their prey, they turn the darkness itself into a weapon. Comb jellies, for example, extend long, delicate tentacles coated with sticky mucus, creating nearly invisible traps suspended in the water. Tiny animals drifting by become hopelessly ensnared the moment they make contact. Unlike true jellyfish, these creatures don't rely on venom. Their adhesive tentacles are more than enough to capture prey in the calm, nearly motionless waters of the deep. To move through this silent world, thousands of microscopic hair-like structures called cilia beat in perfect synchronization, propelling the animal forward with graceful efficiency. When illuminated by the submersible's lights, their bodies shimmer with brilliant rainbow colors. But those dazzling hues are only an optical illusion. The true darkness of the deep ocean, they disappear completely. Here, sunlight has been replaced by something far more extraordinary: bioluminescence. More than 3/4 of all deep-sea organisms can produce their own light, either through chemical reactions within their bodies or through symbiotic bacteria that emit a natural glow. This living light serves many purposes. Species use it to attract mates, others communicate across the darkness. Many employ it as a deadly lure for unsuspecting prey. Perhaps the most famous example is the anglerfish. The female carries a modified spine extending from her forehead, ending in a glowing lure that pulses through the darkness. To a small creature wandering the empty ocean, that tiny light appears to be a rare opportunity. It swims closer, completely unaware that it is heading straight toward a mouth lined with needle-sharp teeth. In a split second, it vanishes. No chase, no wasted energy, only patience. But the anglerfish's story grows even stranger. In an environment where encountering another member of the same species is incredibly rare, the male has evolved along an astonishing path. Tiny compared to the female, he exists almost like a living satellite. Using an extraordinarily sensitive sense of smell, he locates a mate and bites firmly into her body. Over time, the two become one. Their circulatory systems fuse together. The male gradually loses nearly all of his organs, surviving only as a reproductive appendage that continuously supplies sperm whenever the female is ready to spawn. It is one of the most extraordinary examples of reproductive parasitism ever documented in nature. Every adaptation found in this hidden world reflects the same unforgiving rule. Never waste energy. In the midnight zone, even the smallest mistake can mean death. Over millions of years, evolution has transformed what appears to be the most hostile place on Earth into a stage for some of the most sophisticated and astonishing survival strategies nature has ever created. The predators of the eternal night. If the midnight zone is a world where sunlight has vanished forever, then it is that very darkness that has fueled one of the most extraordinary evolutionary races on Earth. Down here, survival is no longer determined by speed or brute strength. Instead, success depends on conserving every ounce of energy and making every hunt count. Food is incredibly scarce in the deep ocean. A fish may wait weeks or even months before another meal drifts within reach. Every feeding opportunity is precious, and none can be wasted. That is why many deep-sea fish have evolved mouths so enormous they occupy nearly their entire heads. One of the most remarkable examples is the gulper eel. From a distance, its body appears slender and almost delicate, but its jaw can expand to several times its normal size. When prey comes within range, its mouth opens like an enormous pouch, swallowing almost anything unfortunate enough to get too close. Its stomach is equally impressive. It can stretch dramatically, allowing the eel to consume prey nearly its own size, or even larger. In an environment where meals are few and far between, passing up an opportunity could mean waiting months for another chance. Another fascinating resident of the deep is the snipe eel. Its long, ribbon-like body is incredibly flexible, allowing it to blend almost seamlessly into the endless darkness. Its curved beak is lined with hundreds of tiny backward-facing teeth. As it glides through swarms of shrimp and small crustaceans, any prey that slips inside its mouth has almost no chance of escaping. Even more remarkable, the snipe eel possesses more than 700 vertebrae, more than any other known vertebrate on Earth. This extraordinary anatomy allows it to move with slow, graceful undulations that maximize efficiency while minimizing energy consumption across the vast open ocean. Body shape isn't the only thing that changes in the deep. Color does as well. Near the surface, many fish display silver or bluish coloration that reflects sunlight, helping them disappear into the surrounding water. But thousands of meters below, sunlight no longer exists. Here, black becomes the perfect camouflage. Some species have evolved an astonishing material known as ultra-black skin. Packed with extremely high concentrations of melanin, their skin absorbs nearly every photon of light that strikes it. The result is extraordinary. They seem to dissolve into the darkness itself. Even under the powerful lights of a deep-sea submersible, their outlines remain surprisingly difficult to distinguish. Yet not every creature chooses to hide. Some have turned light into a weapon. Few illustrate this better than the deep-sea dragonfish. Beneath each eye lies a specialized light-producing organ capable of emitting red bioluminescence, an incredibly rare ability in the deep ocean, where most animals can only detect blue or green wavelengths. This gives the dragonfish something few other predators possess: a private flashlight. It can illuminate and observe prey using red light while remaining completely invisible to its victims, which cannot perceive that color. Many dragonfish take this strategy even further. A glowing barbel hangs beneath the chin, flashing rhythmically through the darkness like a tiny lantern. Curious creatures investigate the mysterious light, only to disappear in an instant. The fang-toothed fish relies on an entirely different weapon. Its teeth are so long they cannot fit inside its mouth, remaining permanently exposed like the bars of a steel trap. Scientists have discovered that these fangs possess an extraordinary microscopic structure that allows light to pass through with almost no reflection. To unsuspecting prey, the teeth are nearly invisible until the very last moment. In the deep ocean, hunting is only half the battle. Avoiding becoming prey is equally important. Many species have evolved rows of light-producing organs along their undersides. Viewed from below, these lights perfectly match the faint glow filtering down from the distant surface, erasing the animal's silhouette against the water above. This remarkable adaptation is known as counter-illumination, one of the most effective camouflage strategies in the ocean. Among the rarest creatures ever observed is the Pacific black dragon. Scientists have recorded this elusive fish in its natural habitat only a handful of times. What makes it especially fascinating is its behavior. Throughout nearly every observation, it remained almost perfectly motionless, as if it understood that even the slightest unnecessary movement could reveal its presence to larger predators lurking nearby. Fish are not the only masters of deep-sea adaptation. Many cartilaginous species have followed a completely different evolutionary path. The chimera, an ancient relative of modern sharks, has survived for more than 200 million years, changing remarkably little over that immense span of time. Running along both sides of its body is an advanced sensory system capable of detecting the faintest vibrations in the surrounding water. Even in total darkness, it can sense approaching prey or danger without relying on vision. To withstand the crushing pressure of the deep sea, fish have evolved countless physiological adaptations. Their cellular proteins have become more stable. Their cell membranes remain flexible under immense pressure. Many species have dramatically reduced gas-filled spaces within their bodies, eliminating structures that could collapse at extreme depths. Gelatinous animals, however, face an entirely different reality. Because most of their bodies are composed almost entirely of water, the enormous pressure that can crush metal has little effect on them. These extraordinary adaptations reveal an astonishing truth. Life has not only survived in one of the most hostile environments on Earth, it has flourished in ways humanity could scarcely have imagined. And the deeper we descend, the stranger this hidden world becomes. Truly deeper in the ocean, nature adopts an entirely different survival strategy. Disappear, not through speed, not through strength, but by becoming almost invisible. One of the most extraordinary examples is the glass octopus. At first glance, it looks less like a living animal and more like a creature sculpted from crystal. Nearly its entire body is transparent. Only its eyes, digestive tract, and a few internal organs are visible. In the pitch-black depths of the ocean, this transparency provides an enormous advantage. Predators struggle to detect it, while unsuspecting prey has no idea danger is drifting silently toward them. Even the glass octopus's reproductive strategy is remarkable. The male possesses a specialized arm that has evolved into a reproductive organ called a hectocotylus, which transfers packets of sperm directly to the female. This unusual reproductive system is found only in certain species of octopuses and squids, yet transparency isn't always the best solution. Some deep-sea animals can actively change their color whenever necessary. Beneath their skin lie millions of microscopic pigment cells. By contracting or relaxing tiny muscles around these cells, they can alter their appearance almost instantly. When they need to disappear, they become nearly invisible. When illuminated by the light of another creature, they immediately darken their bodies, breaking up their outline and making themselves much harder to recognize. It is such an advanced camouflage system that scientists are still trying to replicate its principles in modern materials engineering. Deeper still, squids have evolved hunting strategies vastly different from those of their relatives living near the surface. In shallow waters, many squid hunt in schools, move at incredible speeds, and release clouds of ink to confuse predators. But in the deep ocean, food is far too scarce to support such an energy-intensive lifestyle. Instead, each individual becomes a solitary hunter. They wait patiently, they move slowly, and they strike only when the perfect opportunity presents itself. Yet there is one moment every day when the deep ocean suddenly comes alive. As the sun begins to set above the surface, billions of tiny organisms rise from the depths toward shallower waters to feed. This phenomenon is known as the largest vertical migration on Earth. Every single night, the total biomass involved in this migration exceeds that of all land animal migrations combined. Schools of lanternfish, tiny shrimp, and countless planktonic creatures ascend together. And close behind them come the predators. Giant squids surge into the swarms, attacking with powerful tentacles lined with serrated suckers. For just a few brief minutes, what was once a silent, empty ocean transforms into a chaotic underwater battlefield. Then, as dawn approaches, everything sinks back into the darkness as though nothing had ever happened. But not every creature joins the hunt. Some choose a very different strategy. They feed on what others leave behind. In the deep ocean, every tiny fragment of organic material drifting down from the surface is a priceless source of nutrition. Scientists call this constant rain of debris marine snow. It may consist of dead plankton, fragments of algae, fish waste, or the remains of meals consumed far above. These particles drift slowly toward the seafloor over days or even weeks. For many deep-sea animals, marine snow is the foundation of life itself. One of the greatest masters of this feeding strategy is the vampire squid. Despite its intimidating name, it is hardly a hunter at all. Instead, it extends an incredibly long feeding filament coated with sticky mucus. As particles of marine snow drift past, they cling to the filament. The squid simply reels it back in, carrying the collected debris straight to its mouth. It is an elegant strategy, simple, efficient, and remarkably energy-saving. Even more impressive, the vampire squid inhabits oxygen-poor waters where most other animals cannot survive. Its blood contains an exceptionally efficient oxygen-binding pigment, allowing it to extract oxygen more effectively than almost any other squid ever studied. As a result, it faces very little competition for food. In the deep sea, reproduction presents challenges just as daunting as survival itself. Some female squids carry thousands of eggs for many months. During this time, they feed very little, if at all. Nearly every movement they make is devoted to fanning oxygen-rich water over the developing eggs. By the time the young are ready to hatch, the mother's body is exhausted. Her muscles waste away. Her swimming ability deteriorates. She becomes an easy target for almost any predator. Many mothers never survive long enough to see their offspring emerge. It is the price nature demands to sustain life in one of the harshest environments on Earth. In the eternal darkness of the deep ocean, even motherhood comes with the ultimate sacrifice. In the deep ocean, where there are no forests of kelp, rocky reefs, or coral formations to provide shelter, most creatures must survive in an immense three-dimensional wilderness. There is nowhere to hide, nowhere to build a nest, and no natural barriers to shield them from predators. So how do they survive? Nature came up with a remarkably unexpected solution. Turn other living creatures into your home. Drifting silently through the darkness are giant jellyfish, carried by slow ocean currents. They are not only predators, they also serve as floating oases, providing shelter for dozens of other species. One of the strangest of them all is Deepstaria, often referred to as the giant phantom jellyfish. Unlike the familiar jellyfish with long, stinging tentacles, Deepstaria has almost none. Instead, its enormous bell functions like a giant living bag. When prey drifts too close, the bell suddenly expands and snaps shut within seconds, trapping the animal inside before slowly digesting it. From a distance, it resembles a massive sheet of silk floating through space rather than a living organism. Even more fascinating, scientists often observe small fish swimming around the surface of Deepstaria. At first glance, it might seem as though they are trying to escape. In reality, the opposite is true. These fish deliberately remain close to the jellyfish. They feed on parasites attached to its body, helping keep their host healthy. In return, the jellyfish's enormous bell provides a safe refuge from predators. It is a classic example of mutualism, where both species benefit from the relationship. Jellyfish are not the only creatures that serve this role. Many gelatinous animals become living islands in the vast emptiness of the deep ocean. Researchers frequently encounter tiny crustaceans, shrimp, and juvenile fish clinging to their translucent bodies. Some are simply hitchhikers, using their hosts to conserve energy as they drift with the ocean currents. But not every relationship is so peaceful. Some species are parasites. They attach themselves to their hosts, feeding on nutrients or slowly consuming soft tissues. Remarkably, even parasites must maintain a delicate balance. If they kill their host too quickly, they lose both their shelter and their food source. Even in one of Earth's harshest environments, nature forces life to exist along a razor-thin line between exploitation and survival. Another creature that continues to astonish scientists is the swimming sea cucumber. When most people think of sea cucumbers, they picture slow-moving animals crawling across the seafloor. But thousands of meters beneath the surface, some species have evolved along a completely different path. They possess broad, wing-like extensions that allow them to float and swim freely through the water column. The most famous has earned the nickname the headless chicken monster because of its bizarre appearance. With slow, graceful movements, it glides effortlessly through the darkness while expending very little energy. Instead of hunting, it collects tiny organic particles suspended in the water. It is a simple strategy, yet an exceptionally effective one in an environment where food is perpetually scarce. Even the youngest inhabitants of the deep sea must learn to survive from the moment they are born. The larvae of many deep-sea fish are almost completely transparent. Bodies are as thin as delicate leaves. For months, sometimes more than a year, they drift with the ocean currents, surviving on tiny particles of marine snow before finally transforming into adults. It is an incredibly dangerous stage of life. There are no parents to protect them, no shelter to hide in. A single mistake can instantly turn them into prey for something much larger. In what appears to be an empty ocean, almost any large organism can become a miniature ecosystem. A giant jellyfish, a sinking whale carcass, or even the body of a squid. Each can attract dozens of different species that gather to feed, shelter, or reproduce. In the deep sea, nothing is wasted. Every fragment of organic matter, every dead animal, every drifting body, soon becomes the foundation of life for something else. That relentless recycling is one of the fundamental principles that has sustained this vast and mysterious ecosystem for millions of years. For centuries, The deep ocean was nothing more than a blank space on our maps, a world hidden beneath miles of crushing water, untouched by sunlight and beyond the reach of human eyes. Yet every expedition reminds us of the same extraordinary truth. Life doesn't simply survive in the darkness. It adapts, it evolves, and it thrives in ways we never imagined possible. From creatures that generate their own light, to predators armed with invisible weapons, from transparent hunters drifting through the abyss, to entire ecosystems built upon a single drifting jellyfish. Every discovery reveals that the deep sea is not an empty void, but one of the richest and most mysterious environments on Earth. And despite everything we've learned, we have explored only a tiny fraction of it. Vast regions of the abyss remain completely unmapped. Countless species have never been seen. Entire ecosystems may still be waiting in the darkness, hidden beneath kilometers of water. Perhaps the greatest mystery of the deep ocean isn't what we've already found. It's what still lies undiscovered. As technology continues to push the boundaries of exploration, every descent into the abyss brings us one step closer to understanding a world that has remained hidden for millions of years. Until then, the deep sea will continue to guard its secrets beneath an endless blanket of darkness, silent, ancient, and waiting for the next discovery. If you enjoyed this journey into one of Earth's last great frontiers, don't forget to like the video, subscribe to the channel, and turn on notifications so you won't miss our next adventure into the unknown. Thanks for watching, and we'll see you in the next story.